Howdy.
Howdy.
I hope you stay well. Thank you for coming. Thank you for joining today's discussion. How did you find homework? Anyone started homework problems? Can you hear me?
Yeah, I just haven't started the homework yet.
Anyone started homework problems?
Yes, I've started.
So how did you find it?
It's pretty simple so far.
Okay, good. So homework is due next Wednesday. All right, so before starting today's discussion, let me start with reviewing what we did last time briefly. So I'm sharing our note. Can you see this note?
Yes.
Good. So this chapter is to study system of linear differential equations. So one quick motivating example is tank problems. So some amount of pure water is getting into tank A with a capacity 10 gallon, and then the water pumps are operating to circulate water between tanks. So for example, 2 gallons of water, salt water per minute from B to A and so on. So to understand this situation, we wanted to figure out the determinant, how fast the salt amount change in each tank. So we calculate the derivative, and then we form system of linear equations like this, and then we expressed the system as matrix multiplication. This column, x1, x2, x3, this column matrix will be denoted by capital letter X, and then the column in the left-hand side, x prime, y, x1 prime, x prime, x3 prime will be denoted by x prime. And then we found 3x3 matrix to express the system as x prime equals a times x. So boldface for matrices from now. Okay. It turns out that every system of first order linear differential equations can be expressed as a matrix equation. So it's not surprising that we will solve this system of differential equations using the matrix. So if you understand the matrix fully, we will solve this system. So in particular, we need eigenvalue and eigenvector. So in part 2, sometime next week, we will discuss beautiful theory to see how to use eigenvalue and eigenvectors to solve the system of differential equations. So first, we want to study how to find eigenvalue and an eigenvector. To find eigenvalue, we need to know how to find determinant of matrix. For 3x3 matrix, A, B, C, D, E, F, G, H, I, we can find determinant. So what you can do is to paste matrix A and then adjoin 2 more columns, first column, second column, like this. And then you look at diagonals containing A, E, I, and you take product. Plus another product, B, F, G, and then C, D, H, you add them up. And then you use 3 more diagonals to the left in red color. You take product And then we take difference between two sums. It turns out that this is the determinant of the matrix. Well, this expression doesn't have structure. We push this further to see the structure. Look at this bottom row. We use the first column. The first column has entries A.
Doctor?
Sorry?
And he's a helper. He's like, you need to learn how to do this on your own. And he's a doctor. I know. I was like, what?
Is that a question for me or? I'm not sure. Anyway, so for this expression, we use the first column, A, D, G. So we have A, D, G as kind of coefficients. For this A, you want to take determinant of 2 by 2 matrix. This matrix is not random. To find this matrix, look at this matrix A. You have row 1, column 1 that contain the entry A. You get rid of row 1, column 1, then the resulting leftover entries will give you the matrix EF, HI. You take determinant. Similar for this last term. For this middle term, however, you need to change the sign. Actually, we need this alternating sign business, plus minus plus. And it turns out that you can use any row, any column. For example, in the last example, you can use, you see this 0. So you can use first column or second row to make your calculation simple. Okay, and then one more quick remark is you can use online calculator to check your calculation. So for example, you can simply Google determinant calculator. Let me share this. Can you see this new screen that I'm sharing?
Determinant calculator?
Yes.
Yes, we can see it.
Okay, good. You can simply Google determinant calculator or something, then you will see tons of places. So let me pick the first one. And as you see in the left column, you can do a lot of things: multiply, trace, transpose, determinant, inverse, finding rank, Gaussian elimination, eigenvalue, eigenvectors, everything. So now that we chose determinant, as in this red color, you click this blank, then you can determine size. Say our size is 3 by 3. Once you click the size, you are ready to enter the entries. Let me use the last matrix. Our last matrix was -1, tap 5, 1, 0, 2, -3, 2, 4, 6. Once you click enter, you will see the result. In the very top row, you see determinant of your matrix is -58. You can also check details. This expression is using first row, A, B, C, with alternating sign, and you can check all the details. This is very good place to check your calculation. But at the same time, I should say, you should practice writing down your calculation carefully for homework and for the exam. For the final exam, you will not use this resource. You will not be able to access internet. I mean, you can access eCampus, but you are not going to use this. So you need to write down your calculation carefully. I mean, you need to practice. Okay, so this is what we have so far. Any question? Are you with me?
Yep, we're still with you.
Okay, good. So we will see that determinant will give you eigenvalue. And then next question is how to find eigenvector. Well, I should say finding eigenvector is longer. It takes a long calculation. So we need to discuss this carefully, and you will see how to find eigenvector. So next topic is Gauss-Jordan elimination. You may think this is a scary naming, but bottom line is this is nothing new. You already know all the idea. The only reason they put this name is Gauss and Jordan were born early enough. That's it. If you are born early enough, even before Gauss and Jordan, you can claim your originality. So it's nothing new. Okay, the idea is, well, we can find eigenvector by solving system of linear equations. Look at the system of linear equations in the very next line. 2x plus 3, y equals 1, and x plus y equals 3. This is easy. Everyone knows it. So that's why this method is nothing new. The point is that if you work with system of linear equation for 3 unknowns, it may take long and tedious calculation. So you want to finish your calculation in a short and quick way. That's it. This is all about rewriting. This is all about rewriting your calculation in a short and quick way. That's it. No new idea. Okay. So in the very first column, we will solve this system in the usual way, as you know, and then in the next column, we will rewrite it in terms of metrics. That's it. Okay, let me call this first equation, equation number 1, second one, equation number 2. So, okay. So how do you solve this? Well, eventually, you want to eliminate x or y. So that's how we solve this system. And for some reason, let me start with exchanging two equations. So exchange, first step is to exchange equation number 1 and 2. So then we have equation x plus y equals 3 on top, and 2x plus 3y equals 1 at the bottom. Okay, well, the reason I start with exchanging 1 and 2 is to have 1 here. We will see why we need 1 in the very next column in a minute, but for some reason, we are exchanging two equations. Another reason I'm picking this step is that you can always exchange two equations. But you may think it's silly. I agree. It's very silly, but there is no obstruction to exchange two equations. I'm not saying you have to start by exchanging two equations. I'm saying you can exchange two equations whenever you want, but you don't have to. Anyway, so we have this. Next, you want to eliminate x or y. Let's try to eliminate x guy. So you want to eliminate this x, and we want to have 0 times x in the next step, plus something y equals something else. How we eliminate this x? I'm waiting.
We could multiply the first equation by some coefficient and then add it to the second.
Very good. So let me call this 1 prime and then second prime. So what we can do is to multiply -2 to equation number 1 prime. We added this to equation number 2 prime. Then now second equation becomes a 0x plus 1y equals 1 minus 6 or -5. Is that clear?
Yes.
Okay. And then the first equation, what about first equation? Nothing happens to this first equation. Let's keep this as it is. And let me call this 1 double prime, 2 double prime. The second equation says y is -5. So you can plug that into first equation to find y, x, or equivalently, you can get rid of this y. You can get rid of this y in this green bubble. You can eliminate this y. How do we eliminate this? You can take -1 times second equation, add this to first equation. Then second equation will remain 0x plus 1y equals -5. And the first equation becomes x plus 0y equals 3 minus 5, 8. So we are done. So x equals 8, y equals -5. Yeah, it's quite tedious and not very difficult. Again, the point is we are not interested in solving the equation, the system itself. We want to find a better and shorter, quicker way. So let me rewrite our calculation in terms of metrics. First, let me start with taking matrix multiplication for this original system. Right-hand side, 1 and 3 is column matrix 1 and 3. And then column matrix for unknown x and y. And then you can determine 2 by 2 matrix, 2, 3, 1, 1. Right? Good. And then we are going to step in terms of matrix. In the very first step, we exchange the equation 1 and 2, and then look at this system. We express this as matrix multiplication. So 2 by 2 matrix times xy is right-hand side, 3 and 1. And the matrix is 1, 1, 2, 3. That's it. So compare 2 lines. The previous matrix 2, 3, 1, 1 is now 1, 1, 2, 3. Can you tell me what happened? So 2, 3, 1, 1 is now 1, 1, 2, 3.
So you flipped equations 1 and 2.
Yes, flipping or exchange row 1 and row 2. This is not surprising. Look at this left-hand side, left column. We exchange the 2 equations and that results in exchanging 2 rows. That's it. Next, look at the next system. Taking coefficients, you can express this system as matrix multiplication. We have 1, 1, 0, 1, and then 3, -5. So what happened is, well, the change is we have 0 in this green bubble. To have this, we added -2 times row 1 to row 2. This is what happened. And then one more. Similarly, you can take coefficients to find 2 by 2 matrix. 1, 0, 0, 1, and then 8, -5. Good. So what we did is to add -1 times row 2, add this to row 1. Not surprising. And then no more step. Look at this 2 by 2 matrix 1, 0, 0, 1. This guy has a special name. Does anyone know this name?
Identity matrix.
Bingo. This is the identity matrix. So once you have identity matrix, you can stop. No more operation. Once you have identity matrix, you can stop and write down the answer. So once you have identity matrix, you interpret this to have, well, you take matrix multiplication. First row, 1, 0 times xy is x plus 0y. Second row, 0, 1 with xy is 0x plus y. And then 8, -5. Identity matrix is identity matrix. You have x and y, and then we are done. Good. So if you compare two ways of writing, which one looks better? Or which one looks shorter?
The one on the right.
Again?
The matrices.
Matrix stuff, yes. And actually, we can make this even shorter by suppressing x and y. Look at this x and y. This is redundant at all. So for every step, we repeated x and y, but this is redundant. We can suppress this to get even shorter writing. So this is redundant. Good. So that's what we will do in the very next page. So from now, for simplicity, let's write ith row by r sub I for simplicity from now. Okay, well, this discussion is all about rewriting things in shorter, quicker way. So let's use this notation. Any question so far?
No, sir.
Okay, let's move on. Okay, so the above operation can be written in even shorter way. So original system was 2x plus 3y equals 1 and x plus y equals 3. So we want to rewrite this writing in the right column. Oops, after suppressing the redundant xy. And we will have even shorter and better writing. So you are taking only numbers. 2, 3, 1, 1. And then your right-hand side, 1, 3, is here. 1, 3. Only numbers. You can separate them by putting vertical bar like this. This kind of matrix is called augmented matrix. So what you are doing is take only number and then suppress the redundant. Is this double P or single P? Suppress, is this correct spelling?
Yes.
Double.
Double P? Thank you. All right, so to write our solution or calculation, we are taking only numbers with get rid of X and Y, that's it. And then we repeat our calculation there. First step is to exchange row 1, row 2, and so on. Okay, good. But let me point this out. Our goal is to have identity matrix. This is our goal. So we will apply some operations, but eventually we want to have identity matrix 1, 0, 0, 1 with whatever, like this. Okay. Look at this, our goal. In our goal, we need 1 in the very first entry. That tells you the direction or the operation that you want to apply. Okay. What kind of operation you want to apply?
So you want to exchange row 1 and row 2 first.
Exactly. Exchange row 1 and row 2. You apply this operation to entire matrix or entire row. So 1, 1, 3, and then 2, 3, 1. That's it. Now we have 1 as we expected. And this is exactly what we did in the very first step in page 3. We exchanged row 1 and 2. Good. Next step is to have 0 in this green bubble. So we want to have 0. So to have 0, so we need 0 here. So what are you going to do?
Add -2 of row 1 to row 2.
Good. Add -2 times row 1, add this to row 2. This has, let me rewrite this. Add -2 times row 1 to row 2. Good. So now row 2 becomes 0, 1, and -5. This change takes place only in the second row. So first row will remain like this. So you are taking all the record to keep track of it. Good. So far we have 1, 0, oops, sorry, this is not 0. This should be the first row will remain as before, like this. Okay. So far we have 1, 0, 1, 1. Good. And then next step is to have 1, 0, 0, 1, the identity. And it's clear. You want to have 0, for this one. And what are you going to do?
Add -1 of row 2 to row
Very
1.
good. Row 2 to row 1. Good. Then we have -5 and 8. Good. And we are done because we have identity matrix. Once you have identity matrix, it's time to put x and y back. So 1, 0, 0, 1 times xy is 8, -5. Of course, now that this is identity, we have xy equals 8, -5. Done. This is what we want. We want simplified or shorter, quicker way of writing all the details. Any question? So from experiences, well, students got confused with this idea. Well, the thing is, again, this method is nothing new. Everyone knows how to solve system of linear equations, the same idea. The only difference is we suppress x and y, we express everything inside augmented matrix. And this will give you simpler, shorter, and better way of writing down your solution and calculation. It may take some time to get used to it, but you will see this is very useful and helpful, especially when you work with 3 unknowns, x, y, and z. That's it. You want to finish your calculation quickly. That's why we care this method. Okay. Before moving on to the next example, let me point out one quick remark. Geometrically, the solution, I mean 8, -5, let me use coordinate. Oops, I meant x and y, x, y. 8, -5 is a point on the plane. And actually, this is, I mean, the intersection of 2 lines. Equation number 2 and equation number 1. Oops. You see 2 equations? This is equation number 1. This is equation number 2. And 2 equations will give you 2 lines. 2x plus 3y equals 1. X plus y equals 3. So 2 equations have unique intersection, and that's it. That's our solution. So this solution can be considered as the intersection. Intersection of 2 lines. Good. And then we will keep using this method involving augmented matrix to solve the system of linear equations. All right, and then one more example, example 4. We want to solve the system using augmented matrix. Okay, first step is to suppress x and y, take only numbers 1, 2, 5, 2, 1, 4. That's it. And then eventually, let's see, we apply some operations to solve this. Can you tell me the first step? What are you going to do?
Add -2 of row 1 to row 2.
Very good. That makes perfect sense because eventually, hold on a sec. 1, 2, yeah. Eventually, we want to have identity matrix 1, 0, 0, 1 with something else. That's why we need 1 and 0. So 1 is already there. That's why we want to have 0 in this 2. So that tells you the direction or operation that you want to apply. So add -2 copy of first row to second row. So this change will take place in second row, 0, -3, -6. And first row will remain 1, 2, 5. Good. So we are done with this first column. Fantastic. What's next? Can you tell me the next step?
We could add 2 times the first row to the second row.
Oh, very good. The goal is to have 1 in the last slot. Let me use color. So we want to have 1 there. Well, there are a couple of ways to have 1. So there are a couple of ways to turn this -3 to 1. One way is, as you said, you can take double of first row, add this to the second row. But this will change this entry, right?
Multiply by -1/3 for row 2.
Very good. So you want to turn this guy into 1, keeping this 0. So you can take multiply -1/3 to row 2. Then you will keep this 0 as well. 0, 1, 2. Fantastic. And you keep the same first row. Now we have 1 as you expected. We are almost there. One more step. You want to get rid of this guy. You want to have 0 there. Needle, no, not needle. We need 0. So to get rid of this 2, you can multiply some number to second row and add this to first row. That's it. So then 0, 1, 2 as before, and 1, 0, 1. That's it. Now you interpret using x and y. We have 1, 0, 0, 1 times xy equals 1, 2. Now you can write the answer immediately. xy is simply 1, 2. Done. So this is how to apply augmented matrix, how to use augmented matrix to solve the system. As you see, the calculation itself is nothing new. It's just a slightly different way of writing, hopefully shorter and quicker. All right, any question?
No, sir.
Okay, so it may be useful to keep in mind what your goal is. Your goal is to have identity. In particular, if you have 1, having 1 on the diagonal is very useful. 1 is the easiest number, best number to play with. So once you have 1 on the diagonal, then you can get rid of anything else as you want. So having 1 on the diagonal is a good idea. Okay. So next sentence is about our goal. So intuitively, we want to obtain identity matrix. Identity. But it turns out that not always identity. Sometimes, I mean, in many cases, kind of identity, almost identity. If the size is 2 by 2, we need 1001. If you have matrix of size 3 by 3, and we need 3 by 3 matrix, so sorry, identity matrix of size 3 by 3. It's quite easy. 1's on the diagonal and 0 everywhere else. Well, I should say identity matrices are too good. I mean, they are ideal, but actually our calculation will not give you identity any longer. I mean, in actual problems, we will get some matrix which is kind of identity, but not exactly. 1, 0, 0, 0, 1, 0, and then 0, 0, 0. Look at this bottom row. We have a row with entirely 0. This is called 0 row. So chances are you will end up with matrix like this, or matrix like this, 0, 1, 0, 0, 0, 1, 0, 0, 0. So this is our goal. When you solve system of linear equations, you want to get matrix like the identity, almost identity, like this or like this. So this is our goal. Okay. Any question? All right, let's move on. Are we still in page 4? I think I'm saying too much. Okay, so Gauss-Jordan elimination is to reduce augmented matrix by using those operations. So quick notation. Well, again, we want to find quicker way. So we can use better notations. The first operation that you can use is multiply a row by a non-zero constant. For example, you can multiply some number to first row, second row, third row. So notation is C times Ri. So you're multiplying constant C to ith row. So in the previous example, we had something 0, -3, and -6. Oops, I need more space. -6. We multiplied -1/3 to second row to have 1. And then 2. So this is definitely one operation that we can apply. Second, you can interchange any two rows. The notation is I solve ij. So this is to exchange Ri and Rj. So you exchange the two rows. And you can add a multiple of one row to any other row. So the notation is you can take any multiple, C times Ri. You can add this to some another row, Rj. You can even indicate on which row this change will take place, Rj, like this. Depending on the textbook and depending on online web pages, they may use different notations, but basically there are 3 operations that you can apply. Okay, probably one last example. Hang on a sec. We have only a few more minutes. Let's see. I think it's a good place to pause. One quick announcement. Quiz 8 is available in eCampus. This is available till midnight. So now you are ready to get into eCampus and take quiz 8. All right. So before closing up, any question?
Is there any class on Friday?
Oh, good question. So Friday is a reading day. No class, but I'll record some discussion and send out the link so that you can watch it anytime over the weekend.
Okay, thank you.
Yeah, I'll send out more details in a group mail.
I apologize if this has already been said, but I was just curious. When should we expect to see exam scores?
Oh, good question. Now that it's online exam grading, it may take longer time. Hopefully by this Friday.
Okay, thank you.
Yeah, so we are trying to finish it in a week. Other questions? Okay, I think that's it. All right. Take it easy and thank you very much.
Thank you.
Thank you.
Thank you.